Okay, in this last video of week 5 on our applied machine learning module, we're going to be using MATLAB, where you're going to use the pattern recognition tool in MATLAB in the neural network toolbox to classify breast cancer tumors. We're using the sample data sets that MATLAB provides, and we're going to use two separate matrices. The first one is called cancer inputs, and we have 699 biopsy results with 9 features coming out of each of those. And then we have another matrix called cancer targets that will tell us each of those samples, each of those biopsies, if the tumor was found to be benign or malignant. This is our training data. Then we'll have a different set where we will test, given a new biopsy, whether our model thinks it's possibly malignant or benign. Okay, so let's have a look. We'll go into MATLAB. And now we are going to select in apps our pattern recognition. So we have our neural network. We have here our diagram of the network. So we have our input layer, hidden layer, and our output layer giving us the outputs. Let's click next. We're going to load the example data sets for breast cancer. And we have here our explanation. There's 699 sample biopsies. Each of them has 9 numbers, and then we have the 2 numbers for each of the 699 values. So make sure that you check here that you're using the right 699 samples of 9 elements and not 9 samples of 699. That would be if you chose the rows. Okay, so you need to always check your matrix if you're working per column or per row. Okay, so we have 699 samples of the target, benign or malignant, of 2 elements each. We go next. In this case, we're going to select 20 hidden neurons. You see our diagram, 9 inputs, 20 hidden neurons in the hidden layer, and 2 for the output, because we have 0 and 1, 1 and 1, 1 and 0, and so on. Go next. We're now going to train our network. We can see here the percentage error. We can plot our confusion table, but we'll see those concepts in a few weeks' time. So for the time being, we'll just go next. We go next, next. And what we're going to do is we're going to save, we have the inputs and so on, we're going to save the network. So I'm just going to call it net biopsy. Save. And then we finish. So what we've done so far is we have trained the network. So what we have now is our trained network that has learned from all those values that we entered what the correct weights to go into the activation function are to model our particular problem. So now we're going to get our new set of values. You can find those on. So after we get our new biopsy data inputs from web courses, this is how it looks. We have 15 new biopsy reports with our 9 different features for each of them. And what we want to know is the output, the target, if it is going to be, our model thinks it's benign or malignant. Remember, our network was called net biopsy, so we're going to say new biopsy results equals the name of the network, in this case, in my case, net biopsy, and we'll give it the new inputs, which are new biopsy data inputs. And what we get as our result is this 15 columns, 1 for each of the biopsy results or data sets, and you see straight away there's a difference between our target, our cancer target that we had before, that were perfect ones and zeros, and the one we're getting. But you can also see how they're very clearly, one is close to 1 and the other one is close to 0. So the first value is of type 1, which, if you remember, was benign, and the second one is benign. The third one is malignant, or they need to go and get extra tests. Benign, malignant, benign, benign, and so on. Okay, so this is how you train your network, and how, more importantly, how you use it afterwards. Okay, and this is it for this week. Goodbye.